Hello children, welcome back to our online teaching program. So today in this video we shall discuss some of the numerical problems of the book that are already solved. So the chapter is 13 and the name of the chapter is Motion and the Time. So here we will discuss some numerical problem. Now first there is an in your book there is a given an example 4. That is, here the question is asking a car travel 88 kilometer distance in 1.5 hour. So calculate its speed. So here we have to calculate the speed. So we already know, I have already given you that the speed is equal to distance travel divided by time taken. So here first of all, here it is already the distance is given, distance traveled by the car, that is given, and the time is already given, kilometer and hour. So the units are also same, it is kilometer per hour. So here first of all in the solution you have to write distance traveled by the car equal to 88 kilometer, then the time taken 1.5 hour, right? So then you have to write the formula, speed of the car equal to distance traveled by the car divided by time taken. So here in the formula you have to put the value which I have already given in the question, that is distance traveled by the car is 88 kilometer. So you have to write 88 then divided by time taken. So you have to put the value of the time. So time is 1.5 hours. So 88 divided by 1.5 hours. So here after dividing this 88 by 1.5 we will get 58.7 kilometer per hour. So next example is a boy riding a bicycle covers a distance of 10 meter in 4.0 second. What is the speed of the boy? So here also you have to calculate the speed. So again the formula of the speed is distance covered divided the time taken. So in most of the numerical problems you have to remember the formula of the speed. So speed is equal to distance covered divided by time taken. So for that we have to know the distance, then we have to know the time. So already in the question it is given that 10 meter. So it is given distance covered 10 meter and the time is 4.0 second, time taken 4.0 second. Then we have to, in the formula we have to put the value, distance 10 meter divided by 4.0 second. Now when we divide the 4.0, when we divide the 10, then we will get 2.5 meter per second. And this we can also write in the speed of the boy. Now here it is meter per second. So we know centimeter per second. So this meter per second is second. We can convert it into minutes. So here it is given 10 meter divided by 4.0 second, that is equal to 10 meter. Here 4.0 divided by, this is an sign, that is 60 minutes. So here we know that we all know that 60 second is equal to 1 minute, right? 60 second equal to 1 minute. Therefore here 4.0 seconds. So 4 second is equal to what? 1 divided by 60 into 4. So therefore it is, so therefore this 60 will be go upward. So therefore 10 into 60 divided by 4. So when we multiply all these things, then what will happen? We will get 150 minute per meter per minute will be the answer. Then another example 6. Here the question is the distance between two stations is 240 km. A train takes 4 hours to cover this distance. Calculate the speed of the train. Again we have to calculate the speed. So the formula of the speed is total distance traveled divided by total time taken. So we should, to find out the speed, we must know the value of distance and we must know the value of time. So in the question you have to find out the value of distance and you have to find the value of time. So in the question the total distance travel, it is given 240 km and the time the train takes 4 hours. So 4 hour is the total time taken. So in the formula you have to put the value. So therefore 240 km divided by 4 hour. So if we divide the 4 into 6 into 4, 24 equal to 60. Therefore the answer will be 60 km per hour. Then in example 7. In an example 7, it is a girl takes 15 minutes from her house to reach her school on her cycle. If the speed of the cycle is 2 meters per second, calculate the distance between her house and the school. So here what happened? So here also you have to find a here you have to find the distance. So we all know the speed, the formula of the speed is equal to what? Distance divided by time taken. So here they have given, we have to see that here the question is asking to calculate the distance. So if we calculate the distance, then speed equal to distance by t, then what happened? To remain d is equal to what happened? S by s into t. So here what will happen? Here it is the speed, distance of the school from her house. It will be speed into time taken. So we have to know the value of the speed, and we have to know the time. So in the question we have to find the value of speed and the value of time. So in the question, total time taken, it is given 15 minutes. Then speed of the cycle is 2 meters per second. So it is the speed. So from here now we have to put the value 2 meters per second. Now here 15 minutes is equal to 50 into 60 seconds. Now what happens? Since we have to find it is given 15 minutes and here the speed is given 2 meters per second. So we have to convert the minutes into second, because the speed is in the speed the unit is given in meter per second. So therefore we have to convert this minutes into seconds. So how can we convert? Now 1 minute is equal to 60 seconds. Then 15 minutes equal to what? 60 divided by 1 into 15. Therefore here 15 into 60 seconds. So now speed of the 2 meters per second, then you have to put in the formula 2 meters per second into 50 into 60 seconds is equal to, when we multiply all these things, the answer will be 1800 meters. Then again in the next question it is given the odometer of a car reads 5732.1 kilometer when the clock shows the time 8:30 am. So what is the distance moved by the car if at 8:50 am? The odometer reading is 5736.0 kilometer. Calculate the speed of the car in kilometer per minute during this time. Express the speed in kilometer per hour. So we have to calculate the speed of the car, asking for speed, and they are saying that you have to find in the unit kilometer per hour. So now first of we have to find the speed is equal to total distance divided by total time. It is the main formula. So we have to find the distance then and the time. Now here to find the distance, now first we have to mention the clock reading. To find the reading, it is mentioned that at the starting the time is 8:30 am. So first it is the clock reading, then odometer reading, that is the first distance. It is showing that when the car starts the distance is 57321. So here you have to 57321.0 kilometer. Then next the second reading. The second reading is 8:50 am. And the second odometer reading is 573360 kilometer. So what happens? So distance traveled by the car. So it is when we have to minus from this odometer the final reading 573362, we have to minus 5733. So here it is showing that minus is equal to, when we subtract it, then it will be 15 kilometer. And the time also similarly, because at the starting it was 8:30 and then final is 8:50. To 50 minus 30, what will happen? It will, the 20 minutes difference is there. So time is, it is taking 20 minutes. So now speed of the car is equal to 15 kilometer. Distance is 15 kilometer and the time is 20 minutes. So it will be 0.75 kilometer per minute. Now it is this is in the kilometer, but it is in the minute, right? So this what happened, this minute must be converted into hour. So we know 60 minutes is equal to 1 hour, then 20 minutes is equal to 1 by 60 into 20 hour. So therefore what happened, 15 kilometer 20 divided by 60 hour is equal to 15 into 60, 60 will go upward. So divided by 20 kilometer per hour. So when we calculate this, then we will get 45 kilometer per hour. So this way we have to solve this numerical problem. Then in your book there are some activity also, activity number 4, to draw the distance time graph for a car traveling as follows. So for this, here they have given the time, then they have given the distance and the materials required. That means the things which required for you, that is you need one graph paper, then you need scale, and you need one sharp pencil. So for that, this following procedures have given here. So if you have a graph paper in your home, then you can do this activity. So for that, what the procedure is that we have to first take a graph sheet first. So this is the, suppose this is the graph sheet. So in the graph sheet, at here you have to draw one axis, because I have already explained in your previous video that all the positive values of x are in the ox and the positive value of y will be in the oy. So therefore we will draw this type of axis in the graph paper. Then here in the question it is given the time in minutes and distance in kilometer. First time is that 0, when at the starting it is 0, then 1 minute, then 2 minutes, then 3 minutes, 4 minutes, 5 minutes. That means what distance in 1 minute it will cover 1 kilometer distance. When it will be 2 minutes, it will cover 2 kilometer distance. When it is 3 minutes, it will cover 3 kilometer distance. After 4 minutes, it will cover 4 kilometer distance. After 5, it will cover 5 kilometer distance. So here what will happen? Similarly, because in the graph paper it is a very small graph paper, so for that you have to consider this small box as 1 minute, 2 minute, 3 minute, 4 minutes. And similarly here 2, here it has in your graph paper, here it is taking 2 square box as 1 kilometer, then again 2 square box as 2 kilometers. So this way you have to plot it. So in the right side, that means the independent value will be, quantity will be in the ox axis and the dependent will be in the y axis. So here it is given the time in o axis and distance in the y axis. So here they are considering 2, here it is given 2 square box. This 2 square box is equal to 1 minute, again 2 square box is equal to 2 minutes, 2 square box equal to 3 minutes. So this way you have to plot this way. And similarly 2 square box will be 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer, 6 kilometer. So now you have to plot the value in the graph. How you will plot? It is in the question, it is given starting it is 0. So here you have to start from your 0. 0 is the center of origin. So now 1, in the question it is given in 1 minute it will cover 1 kilometer, 2 minutes 2. So therefore you have to put in the graph paper here 1. When it is 1 minute, the distance will be here 1 kilometer. So here the point will be here. When you put a dot structure, your point will be here. So when it is 2 minutes, so here 2 minutes, this is the 2 minutes. So here 2 minutes, so the kilometer will also be 2. So here you have, your value will be here. Similarly 3, your value will be here. 4 here, then 5 here. So these are the dots you will put in the graph paper. So after putting all the dots in the graph paper, you can see that you can draw a straight line here. So from this, what we can get to know, that that means it is a uniform motion, because in a constant speed they are carrying in the similar interval, equal interval of time, they are covering equal distance. So therefore here what happens, here it is given that draw 2 axes ox and oy, time being the independent quantity. So whatever I have explained, all these things are written here. So on x-axis time square 1 minute, y-axis time square equal to 1 kilometer. So mark the time and the distance axis as shown in the page. Then plot the corresponding to the given values of time and distance as follows. The point corresponding 0, 0 value of time and distance is the origin. To plot the point corresponding to 1, 1 value, draw a dotted line. So whatever I have explained, everything is here. So go through the book. Then here in the result section, you have to the distance time graph for the car is in motion is a straight line passing through the origin. So from when we plot all the value, then what we get? We get a straight line. So here therefore it is a straight line passing through the origin. So in the conclusion, you have to write, from the graph it is concluded that the car starting from the state of rest is moving with a constant speed, because it is a straight line, so it is in a constant speed. So similarly, in your book different graphs are there. Here it is a distance time graph for a body at rest, a straight line parallel to the time axis, because here we can see that when it is in the rest, same time, because it cover, so it doesn't change the time. So therefore this will be this type of structure. So here this is a body moving with an increasing non-uniform motion, because here you can see in 1 minute it is covering, here you can consider it is a 5 meter, so it is covering 5, then in time 2 seconds it is 10, then in 3 it is 20. So what happens, it is covering in equal interval of time, it is covering unequal distances, therefore it is a rising curve is here. So these are the different here different questions example have given in your book, so try to practice in your home. So today in this video I am not giving you any worksheet, so you have to only go through the chapter thoroughly, then you have to learn the all the question answer, and then you have to practice all the examples, numerical examples that have already given in your book. So try to practice in your rough copy, and that's all for today. Thanks for watching.